Hello. Today I'm planning to do another question from operation amplifiers, because operation amplifier questions we might get a chance to face for an MCQ as well and for an essay as well. So we need to practice essay questions. So this is our fourth episode, I guess, for our essay question series. So this question, bit of a challenge. It's not actually a challenging question, but you need to again remember theories and all that, current theories and electronic theories as well. So try this question. This question is not that hard, but you can see moving on we'll be facing bit of a difficult question. This question also we have to do some work. You need to remember some theories. So this question again, I'm telling, it's not that difficult, but try the question. This question will actually recall you lots of theories. So let's get into the answer. Just try the question first and then go through the video explanation. Again, I'm telling you, you will find something new from it. Right. The LDR given in the circuit gives a resistance of 200 ohms and at dark 100 kilo ohms. Find the potential at V1. When the LDR phase light, find the potentials at V2. When the LDR phase dark, find V2. When the circuit in dark, find V out. When the circuit in light, find V out. When will the LED goes on? Alright students, I hope you have tried the questions now. So let's get into our explanation part. Let's see whether your questions are correct. Answers are correct. Right. Okay. The first, find the potential V1. Let's see point V1. Yeah, here this is the point V1. So V1 potential. Right. So the potential here is 10 volt. You can see I have to apply potential divider method. Potential at this point it is 10 volt. It's 10 volt here and here it's grounded, so current will flow in this direction. 10 ohms, 10 kilo ohms, 10 kilo ohms. So I'm going to apply potential divider method. So resistance ratio R1 is to R2, it has to be equal to V1 is to V2, you know this. So 10 kilo ohms to 10 kilo ohms, 1 is to 1 ratio. So at the same manner the potential ratio will be divided into 1 is to 1, half and half. So what I have to do is 10 multiplied by half, I get 5 volts. So 5 volt each for 10 kilo ohms resistors. So if this 10 kilo ohms keeping 5 volts, the potential here is 0. So the potential here V1, it has to be 5 volts. So we have the first answer, it's 5 volt. Our first answer, it has to be 5 volt. Right. So update your answers. If your answers are correct, that's great. Moving to our second answer, second question. When the LDR phase light, find the potential V2. Right. LDR phase light here. So the data they are giving us, when the circuit gives resistance 200, LDR in the circuit gives resistance 200 ohms, and at dark, yeah, it's for light, it's 200 ohms then, right? So 200 ohms. 200 ohms at when the LDR phase light. Okay. Again, I'm going to apply the potential divider method. Here potential 10 volt and here grounded 0. So I'm going to apply the ratio. 20 kilo ohms, 20 into 10 to the power 3 resistance ratio I'm going to apply here, and 200 ohms. Right. So I'll make 204. That's easy for me to simplify. So it's 1 is to 100. You can see that, right? Then what I have to do is I'll get the fractional value 1 over 100, actually 1 over 101 and 100 over 101. Right. So I have to multiply it by 10. Right. I'm going to multiply 10 into, so I have to find the resistance at LDR. So I'll multiply it. Actually, I can here assume it's 100 here, this value, because it's almost closer to 100. So 10 divided by 100, I'm getting 0.1 volt. So the potential at V2, I'm getting 0.1 volt at light. So I'm updating my answer, 0.1 volt at light. And when the LDR phase dark, Now it's third question. When the LDR phase dark, when it's dark, okay, the LDR will give a resistance of 100 kilo ohms. So I'm going to apply the very same resistor ratio method, R1 is to R2. So resistance here it's 20 into 10 to the power 3 is to 100 into 10 to the power 3. So 10 to the power 3, 10 to the power 3 cancel off, you can see that, right? So my ratio now it's 20 is to 100, 1 is to 5. So I need the fractional value to multiply. So it's 5 over 6 here and 1 over 6 here. Easy, multiplied by, so I have to multiply 10, 5 over 6. So it's 50 divided by 6, 8, 23. So 8.3 answer. Right, let's update our answers. 8.3 potential. When the circuit is in dark, find V out. Typos. Right, let's move into right. All right. Find V out. Right. So when finding actually V out, then only now only we are applying our electronics knowledge. So this is actually open operation amplifiers open loop situation. How you identify open loop situation? There's no direct connection between output and inputs, so it's not connected anyway, right? This is just output, so not connected, right? So there's no feedback or anything, so we have to assume this is open loop. So open loop equation is this: V out equals open loop gain into V1 minus V2. You know V1 is positive value, V2 is a negative value. Inverting input, non-inverting input. So V1 is non-inverting input, V2 is inverting input. Right. When the LDR phase dark, right, find V out. When the LDR circuit phase dark, find V out. Right. So at dark, actually the value of A is not given. So in generally we consider the value of A as more than 10 to the power 3. Let's assume very same. So it's 10 to the power 3. So V1 we found it's 5. So 5 minus V2 at dark. So at dark it's V2 we found 8.3, right? So 8.3, you can see it's a negative value. So 3.3 minus into 10 to the power 3, so it goes to a very high value of negative. So we can assume it's minus 10 volt because it's getting to the maximum value of minus. So I'll assume it's minus 10 volt, right? Minus 10 volt. That's our fourth answer, minus 10 volt. Right. Let's update our answer now. It's minus 10 volt. Right. When the circuit in light, right, when it phase light, now we know same equation, V out equals A into V1 minus V2. That of course you know. A we assume 10 to the power 3, V1 5, and V2 of course at light. I hope remember. Let's find our answer. At light it's 0.1 V2 value, right? So let's update our value, 0.1, right? So again 10 to the power 3 into 4.9, it's a very high value but positive. So positive maximum is 10 volt plus 10 volt. That's our answer. Right, it's now it's plus 10 volt. Let's put our answers. Plus 10 volt, right? When will the LED goes on? Right, let's get into the, so we can find that answer from here as well. So if the potential, now you can see this is LED, it acts as a diode. The diode will send the current in forward bias direction. So potential here A, let's say B, A has to be greater than B. So here the potential, when it's, let's say initially it's minus 10 volt and plus 10, we have two values. At dark it's minus 10, you can see that. So when the dark it's minus 10 volt, you can see that, and at light it's plus 10 volt. So you can see it goes on when at light, right? That is our answer.